I know you've seen on like your phone games or on the internet, these things, pictures like these, and they're like, hey, can you draw these without lifting up your pencil and without going back over a line? So when I mean like going back over a line, I cannot go back in that direction because I've already made a line going there. So I first encountered with it looking at this shape. I'm just letting you know. We can start here, go up, go over, follow these arrows. And you see we can do that without going over any line in any direction. I mean, not any direction, excuse me. Going over any line or without lifting up my pencil. So when we're looking at these, we are calling them things like Euler's path and Euler's circuit. So the first thing we would do is label their vertices. We want to know the degree of each vertice. So remember, we're going to look here to find a degree. You're determining it has 1, 2, 3 edges. So this A has 3 degrees. I'm going to use odd numbers. I'm going to use pink to represent odd numbers and green to represent even numbers. Now, with that being said, once you've labeled all of your edges, vertices, the degrees for all the vertices, by counting the edges, you have to ask yourself and see if you can notice if it has all even vertices. If it has all even vertices, then it is something we're called a Euler's circuit. Then that means that you can, yes, you can do the activity of drawing this picture without coming across any other line that you've already drawn or edge that you've drawn and without lifting up your pencil. Now we can also talk about a Euler's path. Euler's path has exactly 2 odd vertices and the rest are even. So if we look here, with that in mind, if I wanted to complete this first one, it would be considered a Euler's circuit. I can start in any position on any vertices and I can complete this and I can do it. 2, 2. So we would start and end at the same vertice. Okay, let's go for D. Okay, so Euler's circuit, you can start at any vertices. Okay, however, let's look here. If we have all odd, that's nothing. You can't do that. You'll be wasting your time. If you have 2 odds, like this one, this is called a Euler's path. It doesn't matter where they are. It is a Euler's path, as long as there's 2. Now, the trick for this one, you have to start and stop at an odd. So, 2, 2. See, right there, we have to start and stop at that same odd. I apologize. I messed up on that one. Let's try that again. 2. There we go. At an odd. Let me go from this direction. Starting and stopping at an odd. So you must start at an odd. An odd degree. You can see here that your odd degrees do not have to be the same number for it to be a Euler's path. Now, when you're doing one and you're looking, and I get to like 1, 2, and then the third odd degree, I'm automatically stopping because you cannot do that. That's not possible because you need exactly 2 odd. That's it.